Hi, I'm Robert Woodcock, and I'm here to talk to you about the CEOS interoperability terminology. So, what is interoperability? Well, that's a really good question, and it's asked a lot inside CEOS because there are a lot of mixed up terms, which is why we have an interoperability terminology report being worked on. So what has happened is there's been the term analysis-ready data kicking around for a while now within CEOS, and its meaning has become somewhat meaningless because it and terms like interoperability can refer to many different levels in an architecture or a data format or an API or a geophysical measurement and so forth. And so the terms are used quite inconsistently, and it very much depends on the listener and the speaker as to what is trying to be communicated. And their different biases will have a really significant impact on how effective that communication actually is. Part of the challenge here is that interoperability represents a continuum of compatibility around products, services, algorithms, and so forth. And our goal with defining terminology is really just to try and help provide CEOS members with a little bit more consistency in how they can communicate terms by providing some more specific terms for some specific cases that are particularly emergent at the moment. Really, it's about making an unmanageable situation into a manageable one. Now, it's worth noting that the interoperability terms are not intended to provide a standard in the sense that the ISO or the OGC do. There are standards bodies that do this, namely those two. And they are wrestling with many of these new terms as well. WGIS, through its CEOS representatives, are engaged with those standards bodies and contribute to the broader standards development globally. But CEOS can't continue to wait for that to happen and those longer conversations and consensuses to finally decide on a set of common terms that are in use. So we're setting up some now while we need them, and we will evolve the terminology as the community at large develops new terms. So we're only focused on a few terms in this particular terminology report. WGIS actually maintains glossaries of terms for a number of other topics, and you'll find those on the WGIS website, on the CEOS, on the WGIS section of the CEOS website. But the interoperability terminology report is really just about some emergent areas around Earth analytics, cloud data formats, and ARD itself. So working across the working groups, and in particular between WGIS and LSIVC and WGCV, we've come up with some initial terms, which we're putting out there and which will be taken to plenary to make draft version 1 of this project, of this report. And hopefully encourage the use of the terms, and hopefully they'll evolve over time and become more robust in their definition and explanation. So for ARD, 5 terms have been defined in the document: analysis-ready data, just in the general sense of the term. And then there's stuff around CEOS ARD for land products, aquatic products, etc. What it means to be an interoperable product, what it means to be a harmonized product, and a fused product. And what you'll find in reading the report, and I won't go through all the definitions here, but you'll find that effectively we start from what is raw imagery for an optical satellite, which has little or no interoperability in its initial format, through to the ability to have geophysical measurements that are consistent for the types of satellites that they came from. So all the blues from all the blue sensors in all the optical satellites are harmonized, they're positionally aligned and temporally aligned, and you have a completely unified data set that you can just use in that form across those 2 or 3 or 4 different satellite sensors. So it really is a continuum, and these 5 terms are just there to help people to place themselves in that continuum when they're talking to one another, and that way hopefully have slightly less confusion. We're also hoping within WGIS that we'll be able to demonstrate these different types as they often build on one another. You start with raw imagery, you end up with a fused data set, they build off of one another. And so the goal is to be able to demonstrate these levels in a practical sense, probably using the Earth Analytics Interoperability Lab that is talked about in one of the other presentations. Another set of definitions that has become increasingly important is around cloud data formats, particularly for when we're talking about ARD in the cloud because these two are mixed. The discussions are in ARD often come back to, and what format is it stored in, and can I run my analytics on it directly? So we've defined 3 terms in here. Cloud friendly is an example of that would be cloud optimized GeoTIFFs. These formats are not optimal for performance in the cloud, but they have been tuned sufficiently to allow their use in a non-prohibitive manner. Cloud systems, for those of you that aren't aware, aren't like ordinary file systems. They use object storage. It has a different set of characteristics for performance, and if you don't adhere to those paradigms that are within object storage, your performance can go through the floor very rapidly. It can actually be extremely hard to use, for example, a netcdf file in the cloud directly, because cloud object storage simply doesn't support the commands that a netcdf file is expecting to use to access the file system that it's stored on. As a result, there's been some changes being made around that place. GeoTIFFs are kind of handy because you can reformat them internally so that they are actually more cloud friendly. And with changes in the libraries that use GeoTIFFs, so example raster.io or GDAO, you can actually get quite good performance in the cloud from a GeoTIFF stored in object storage. This approach also has the advantage that because they are still GeoTIFFs, you can download them and load them into any program that will use a GeoTIFF, even if it doesn't have the optimizations associated with cloud access like raster.io and GDAO now have built into them. So you'll notice there that I've said that both the format in the cloud changes, but also how you access it, the library has to change as well for you to take advantage of that. A cloud native format, these are new formats that are specifically designed for cloud access. A good example of that is ZAR. ZAR is particularly good for climate data and Earth observation data and can replace formats like netcdf directly. Applications, of course, need to be able to support ZAR, so it's not a very interoperable format just at the moment because there aren't that many applications that support ZAR format in them. But that is changing very, very rapidly, and we expect to see a lot more ZAR. For example, the Open Data Cube currently works with GeoTIFFs and has a beta release of a ZAR format driver being underway at the moment. On top of that, you have a Cloud Data Access API. With things running in the cloud, you can basically do on-the-fly data format transformation, and with some heavy use of caching, achieve similar performance to cloud native systems, but without actually having to change the file formats that are being used. Now, this clearly isn't the best. There's a trade-off on cost and latency associated with all that data transfer and transformation that's going on. Of course, it's cached, so there are times when it's just not fast enough. Because you're not going to cache the entire planet simultaneously. But it is another option that exists. And there are, for example, netcdf in the cloud is another way that works using a Cloud Data Access API. So each of these terms are technically viable in the cloud and as cloud data formats. And WGIS will be working on a best practice guide on how to make use of data in the cloud and also data discovery and access in the cloud, which has some additional changes in it given the replication of data across cloud providers and so forth that is occurring quite rapidly at the moment. Another set of terms, and the final set in this document, is around analysis interoperability. There's been a discussion for some time now on interoperability between data cubes, for example, and that has different levels within it. And again, we're defining a set of terms here, just 3 in this particular case, around the different kinds of interoperability that might be achievable for analysis of Earth observation data. So one of them is obviously executable code. It's a black box service. It's available at the end of an API. It's called NDVI, and you run NDVI and it spits back a result. There's no actual code portability. It's just that the application can request an NDVI. It gets one back. How it's done, it doesn't care about. All right. Another form of analysis interoperability is the actual source code. Somebody's written NDVI in Python, and you can take that source code, pick it up, and run it on a different system. So you can take it and run it on the CSIRO's Easy Hub, which is powered by the Open Data Cube, or on the ESA Data Cube, and it would just be exactly the same. Now, please note, that actually isn't possible at the moment. It won't be exactly the same. Those two systems are not interoperable at the source code level. But that's one level of interoperability that might be aspired to. for across CEOS. Another one is just straight up algorithm. Somebody may have written an algorithm that computes NDVI. Somebody else has written an entirely different algorithm in an entirely different programming language that computes NDVI. Do they produce the same result? Yeah, it's not guaranteed that they would under all circumstances. Now, this is particularly important for things when you start getting far more advanced than NDVI, when you start getting into water quality analysis and so forth. Is that water quality algorithm comparable scientifically to another water quality algorithm? Now, this is slightly different. This is not source code. This is not executable code. This is the actual algorithm, the actual science that's running. How interoperable are they between different implementations? So we're hoping to take this a step further beyond the definitions and actually validate data cube interoperability in the Earth Analytics Interoperability Lab and its broader ecosystem. Now, that does require additional nodes for the Interoperability Lab. We've only got one at the moment with one implementation. But if we have others, then we'll be able to start to look at these different types of interoperability and see what's most effective and in particular cost effective. Some of these could be very expensive to achieve with no real gain. So we need to assess that and understand that a little bit better. But for now, we've got a set of terms that helps us to describe what's different. So the Interoperability Terminology report will be available on the CEOS website, and I highly recommend you give it a read. We welcome feedback. We recognize that some of the definitions are probably not as strong as they need to be or communicative as they need to be. So send through your feedback. It's a living document. We can update it at any time with improvements. So feel free to send us any feedback you have or suggestions for additional terms or refinements that might be out there that you'd like to make. But I also encourage you to make use of the terms in your CEOS communications so that other people are encouraged to use them and we get a little bit more consistency and a lot less confusion across CEOS meetings. Thank you for your time. Enjoy the rest of WGIS 50.